Okay, so we have a circuit with 3 capacitors. We have a potential difference across the 20 microfarad capacitor, that's 12 volts. We want to know what the potential difference is supplied by the battery and how much energy is stored in the 25 microfarad capacitor. So we know this capacitor has 12 volts. If we know the capacitance and we know the voltage, we can find out how much charge. The charge is going to be the capacitance times the voltage. So 20 times 12 means there's 240 microcoulombs of charge on this one. Now we know the 20 and the 30 are connected in series. They're along the same path. There's no branch between them. So what do I know about the 30 microfarad capacitor then?
It has the same charge as the 20.
It has to have the same charge as the 20. So it also has 240 microcoulombs of charge. Since we know the capacitance and we now know the charge, we can find the voltage using the same equation. The voltage will be Q over C. So Q, 240 over C, 30. The voltage for this capacitor will be 8. Now, according to the conservation of energy, whatever the battery puts in, if we go through this middle branch, so if we just follow a path from one end of the battery to the other, whatever the battery puts in, the elements have to take out. So this one's taking out 12 volts, this one's taking out 8 volts. So how much did the battery put in? 20. So there's our first answer. The battery has a voltage of 20 volts. So what do we now know about the 25 then? It has to have all 20 volts. If we take our little path and go around the outside loop, the only element in there besides the battery is this capacitor. So if the battery puts in 20 volts, this capacitor has to take out the 20 volts. We wanted the energy that's stored, so energy is U, so 1/2 C delta V squared. We know the capacitance is 25 microfarads. Voltage is 20 volts. We need to square that. Putting in 10 to the negative 6 for micro, we get 5 times 10 to the negative 3rd joules, or 5 millijoules would be the amount of energy stored by the 25 microfarad capacitor. We could easily find the energy on the other 2 capacitors as well, using the same equation, because we know their capacitances and their voltages, so it would be easy enough to find. Questions? This one was kind of nice because we didn't have to break it down into one capacitor.
I did that anyway.
I did that.
Okay, you could still break it into one capacitor if you want. Just wasn't necessary.